of the session. So we'll talk about lenses, combination of lenses. We are going to solve only previous year questions. So it's going to be a really interesting session. And we are also going to see the theory for the lenses as well as prisms, deviation, dispersion and all this stuff in today's one-shot marathon session exclusively for you. So it's going to be a rigorous session. So stay alert, keep chatting with each other, make sure everybody is active and keep the spammers away. So you are going to be the army. So that's what you need to do. Welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu, going live for all of you. So this is a very special channel. Why is it a very special channel? Because this is meant for all the students who are going to crack, who are willing to give in all that they have, put in all that effort for cracking the examination. Be it JEE, be it boards, be it BITSAT, be it NEET, doesn't matter. And this channel is in English for all the English medium students out there in our country. So welcome everyone. Hello Laksh, Ankit, Mohit, Tanmay, Krito, we have Aishwarya, Sakshi, Wiki Channel, Laksh. Hello everyone. Hi Nitish. Hello everyone. Welcome aboard. Hi Richu. So I know many of you are very familiar faces out here, but I know also that some of you are probably new to this channel. So guys, I teach physics on this channel as well as on the Vedantu platform, and I have been teaching for quite some time, like you can see on my introductory screen, and many of my students have also qualified and also aced the examination with 2-digit All India ranks in JEE Mains as well as JEE Advanced. And I really hope that I bring in that change within you as well. So welcome to this channel, we Enthuse. And if you want to get in touch with me, you can also get in touch with me on Shreyas_Vedantu. That's my Instagram handle. So you can definitely tag me in some interesting meme, picture, motivational quote, video, whatever you feel like. Definitely do consider tagging me or sending me a message out there. And before we begin this class, guys, our tradition, what should we do first? 3 steps. Like. Number 2, subscribe. And number 3, share. I know many of you minions have already subscribed. So other people who want to become a member of this channel free of cost, just hit the subscribe button and go smash that like button, because we are going to get all the energy we need to conduct these marathon sessions, PYQ sessions, KVPY sessions, and so many other interesting sessions only for you, only because you have likes, comments, and because you will share this channel with all your friends. So that's how we are going to grow our minion family. So come on, go ahead, do that. Hello Shreyas, wow, we have a person by my name also. Hello Education World. Welcome. Yes, good evening everyone. So let me quickly glance through the timetable. So optics, how many sessions will it be done? Aishwarya is asking. So we are going to complete optics in 3 sessions. This is the 3rd session, by the way. 2 sessions were already conducted last week or the week before that. So please watch the replays in case you have missed mirrors, refraction and stuff like that. So today we are going to conduct lenses, combination and prisms. Now tomorrow is a very important session. Yes, it's a very important session. Just like we revise the complete 11th syllabus, tomorrow we are going to revise the complete 12th syllabus in just one lecture. All the formulas will be given to you. But keep in mind one important thing. This lecture is not at 7 o'clock, because a lot of you were asking, sir, can you conduct this lecture? So I thought of conducting it little bit early. So it's going to be at 5:30 p.m. Please keep this in mind. And Wazim sir's class will be at 7:30. So 5:30 p.m. tomorrow, a very massive important lecture, complete 12th formulas revision at 5:30 p.m. Wazim sir will be conducting his class at 7:30 p.m. Keep this in mind. And if you have missed any of these classes, do watch the replays in the playlist or in the past videos out there. Yes, today is marathon. Hello, welcome everyone. Yes, let's begin. Hello Likita. Yes. So let's start with lenses, guys. Get ready. I hope you guys are ready. So I'm pretty sure many of you would have seen lenses in your day-to-day life, maybe in cameras, maybe as a magnifying lens, or maybe as spectacles, or maybe as contact lenses, or somewhere or the other. and you would have seen those curved surfaces create, that magnifying effect. Sometimes the images could be diminished and they can be used for various purposes, like in a microscope or a telescope or your optical lens and so on and so forth. Now there are two kinds of lenses, and you would have seen that, by the way. So we are going to talk about convex and concave lenses in a bit, but before that, a small quiz for all of you. The focal length of a lens, what do you think, guys, it depends on? Does it depend on the nature of the material of the lens? Does it depend on the color of the light? Does it depend on the medium in which the lens is placed? Or is it all of the above? So what do you guys think? What do you guys think? Yes, Biswajit, even the eye is a lens. Correct. Okay, some of you are saying A, some of you are saying D. Very interesting. Oh, by the way, I grabbed some chips meanwhile because I know it's going to be a long session. Come on, guys. So, you guys are saying D or A? Yes, Nitish, you can refer to DC Pandey as well. So, well, the correct answer is all of the above. Now, why is the answer all of the above? You will get to know during the class. So, for that, you need to attend the marathon session. The answer for this will be given in detail during this session. So, keep watching. Now, let's get going ahead. Okay, so guys, what and all snacks have you got today for this marathon session? Please type it out in the chat box. Even I want to know, and other new members would also love to know. So maybe they can also grab some sandwich or something for, staying longer. So please let me know in the chat box. Meanwhile, let me also tell you about the JEE plus CBSE crash course, which is actually started. But some of you probably do not even know about it because many of you are probably new to this channel or probably even new to YouTube, or maybe you just did not think about it so much. So guys, a lot of you know about the JEE crash course, which is conducted in many institutes, even in Vedantu. But we have come up with JEE plus CBSE crash course. So, what is the added benefit? Whatever things you get in a JEE crash course, what is that? That is live sessions, interactive sessions, class teachers to solve your doubts in the class, doubt solving ability after the class, also test series, test discussion, special strategy sessions, and so many more. And also the booklet and the assignments and daily notes, replays, all these things are available. Apart from that, you get 107 CBSE sessions which you can take part in, and along with that you get the related test series for CBSE, their discussions, CBSE related score improvement strategy sessions and stuff like that. And also remember, you can ask your doubts from morning till night. That is very important, guys. And it could be from JEE, from CBSE, doesn't matter. And these are live classes, and even if you miss a class, you can watch the replays. So that's the best part about this JEE plus CBSE crash course. So go ahead, check it out. Use the coupon code SHCC to get maximum discount as possible. So by the way, this is the price for JEE crash course. Only the JEE crash course is 10,000, but with discount of 30%, you get it for 7,000. Okay, so that's after discount. But if you want JEE plus CBSE crash course, that price goes to 9,600. It is not double of 7,000. So understand, we have placed the price of this course very nominal. So just at additional mere 2,600 rupees, you can avail the benefits of the CBSE crash course as well. No need to join two classes, two teachers, nothing like that. In just one crash course, you can cover everything. So guys, I feel that this crash course is going to be really useful for all of you. Yes, Ashok, you can definitely attend. And I feel that you need to check out at least the details of this crash course in the description box below. Just have a look at it. I'm not even saying join it. Just have a look at it. If you feel that this is going to be really helpful, and if you still have some doubts, do contact me on my Instagram or just leave a comment. I'll definitely reply to your comments, and you know that. Okay, so let's get going with the next part. Now, talking about the types of lenses, there are two types. One is converging lenses, second is diverging lenses. Now in converging lens, you can have a convex lens. So this is how a convex lens looks like. Both sides are convex. Now this is a biconvex lens. So what's the difference? So the difference is if both the surfaces have equal radius of curvature, then understand it will become a equiconvex lens or a biconvex lens where the surfaces on this side and this side are equal. Now over here it's one radius over here and the other radius over here, so this is not a symmetric lens. This one is symmetric. This one is a plano-convex lens. One side is flat, one side is curved. So that's how it is. Yeah, okay. And Fida, okay. I'm not sure where you sent Fida. Did you send it on Instagram? I'll definitely check it out. Fida, don't worry. I will not ignore. And since many messages come, so sometimes it happens that I take some time. I respond to the messages in batches. So maybe I would have not seen your message till now. So don't worry. I'll reply to your messages as well. Okay, so next is diverging lenses. So concave lens, where again you have both surfaces curved but of different amount. Biconcave, equal amount of curvature, and plano concave, one side flat, one side is concave. Now if you take a convex or a concave lens, like I said, convex lenses are converging, concave lenses are diverging in nature. So if the rays of light are parallel, a parallel beam of light enters a concave lens or a convex lens, this is how it behaves. For a convex lens and for concave lens, look at this. For concave, the rays diverge and they appear to meet from behind, and for convex they meet ahead. So that is the focal point. For concave, the focal point is behind, this is the focal length. For convex, this is the focal length, this is the focal point. So focal length for concave is negative. Look at that, focal length is negative. Okay, but for convex lens, it is positive. It's towards the right side or on that side of the lens. I hope you understand this. Okay, so I hope this is clear. Ankit, yes, there is a subscription for 2022 as well. I can tell you more details about it. Probably you can ping me on Instagram or leave a comment after the video. I'll definitely put up all the details, whatever you need. Okay, just ask in detail in the comment section. Now, like I was saying, for convex lens, let's talk about it first. All the rays, when enter parallelly, they meet at this point, which is the focal point. This is a focal length is positive, keep this in mind. And there are two radius of curvature. Let me draw that for you. This one is R1, radius of curvature of the first surface, because rays of light enter this surface first. So this is your first surface, remember that. And this is your second surface, because the rays leave the convex lens from this surface. So the radius of that surface is going to be called as R2. Lot of people think this is R1. They think this is R1 and this is R2. So be careful about it, guys. So you need to know which is R1 and which is R2. R's are the radii of curvature of those lenses. Okay, I hope this is clear. Next up, if you keep an object anywhere, then how do you find the image using ray diagram? There are three simple rays that you can draw to figure out the image, and you would have done this in 10th standard. You draw a ray which goes parallel. After the lens, it goes through the focal point. That's one ray. Another ray that you can draw is show it passing through the passing through the pole. If a ray goes through the pole, then it goes undeviated. That's the second ray. Like you can see over here, the ray through the pole goes undeviated. Third ray that you can draw is if you show a ray passing through the focal point on this side. Please understand, actual focus is here. This focus is called as the secondary focus. If you show a ray passing through the secondary focus, then after refraction it becomes parallel. This comes because of reversibility of light, because if light came from here, then it would pass through this focus. So that is why for every lens there is a primary focus or the actual focus, and at the exact same distance behind it you have the secondary focus. I hope this is clear. So these are the three most important rays to figure out where the image is going to be formed. I hope this is very clear. Yes, so we're going to talk about it, Mohit. In what conditions can a diverging lens act as a converging lens? In fact, we're going to do a problem on this. Yes, nostalgic. And you should know all the ray diagrams for a convex lens. Please draw it. You might think you have drawn it in 10th, so it's no longer important. That's not the case. Draw it. Most likely you will learn new things. Also, you would realize that you have forgotten few things. So draw the ray diagrams for all the scenarios. object at infinity, at 2f, beyond f, at f, between f and pole, etc., etc. And for every scenario, figure out whether the image is real, diminished, inverted, same size, virtual, etc. So that is very important. This should be there in your notes, and I will be keeping them in the session notes as well. That is your extracts. Okay, so that is one thing. Now talking about concave lens, like I was telling you, the rays which are parallel, they diverge. So they appear to diverge from this point. So this is your primary focus. Okay, this is your primary focus. The secondary focus will be here, and the focal length will be negative. Okay, the focal length is negative. This is primary focus. Secondary focus will be here, and understand this will be radius of curvature 1 and this will be radius of curvature 2. If by chance I ask you what is the sign of R1 and what is the sign of R2, guys, what do you think is the sign of R1? Is it positive or is it negative? Come on, let me know in the chat box. Is the sign of R1 positive or negative? Come on, think about it. Narinder, you will get all the extracts in the Telegram group, number 1. Number 2, you can also get it from the description box at the end of every chapter. So the last lecture of every chapter will contain the entire summary of that chapter. Okay, some of you are saying negative, some of you are saying positive. Guys, the answer for R1 is negative. Why? Because look at where the center of curvature is. Center of curvature is on the left side, negative side. So if you take this as the origin, this as x and this as y axis, see where the center is. It's on the negative side. So that's why it is negative. And R2, look at where the center of curvature is. Center of curvature is on the positive side. Hence R2 will be positive. Keep this in mind. Okay, understood guys? Clear everyone? Shall we go ahead? I'll eat a chip and let's go ahead. Next, again same rules for a concave lens also. Draw a line parallel to the principal axis. It diverges. Okay, it diverges and it diverges from the focal point. If you draw a line which passes through the pole, it will go unaffected. Okay, so those are the same rules which will be valid here also. So if you want, I'll show it to you. A ray which goes like this, when extended, it will pass through the focus. The ray which passes through the pole will go under. So all these rules are valid over here also. So this is how you can locate the image. Actually, you just need two rays for locating the image. You know that a ray which is parallel becomes divergent. A ray which passes through the pole goes undeviated. So see where they meet. If they meet here, that is where the final image will be located. Probably all of this would be done by you in your 10th standard. So this is like a basic revision for all of you. Cool? Great. Yes. Now let's do a question based on this. In the above 4 ray diagrams, for a diverging lens, which one is correct? Only one of these 4 ray diagrams is correct. Which one do you think is correct? This is A, this is B, this is C, this is D. Come on, think about it. Mirror reflection, lens reflection, is this relation correct? Mohit is asking. I'm not sure, Mohit, what exactly you're asking. Can you get a rank under 100 by subscription? Ankit, yes, you can. Just no need to be angry, beta. Whatever doubt you have, I'll answer it. Okay, let's have a look. Let's have a look. Many people are saying B. Some of you are also saying C, by the way. Let's have a look, guys. Okay, the correct answer is actually C. It's not B. Now I'll tell you why. See, in option A, the ray over here goes undeviated. That is correct. This ray passing through the focus becomes parallel. Achha. And let's try to think about this. Is the image formed like this or somewhere else? Okay. Now, if you look at these ray diagrams, one only is correct. All others are wrong. Something is wrong. Okay, guys. Use the principle of reversibility. Reversibility principle says that if the direction of the rays are reversed, it will travel the same path. Now imagine if a ray enters the concave lens like this. if the ray enters the concave lens like this, what will happen? It will diverge this way, right? And it will diverge from this point. Understand? It will diverge from this particular point. So guys, this ray should come here, not go there. So hence option A is wrong. I hope this is clear. Next up over here, option C. One ray is going like this, it diverges there, and okay, this ray is going undeviated. I think this should be correct. Look at this, both the rays are correct. This ray goes like that. When extended backwards, it meets at the focal point. This ray goes as it is undeviated. So there is nothing wrong about this. So option C is correct. Okay. Now look at option B, guys. At option B, this ray is fine, but this ray is again not fine. Because if a ray comes ulta, opposite, then that ray should go here and it should diverge from this particular point. So that is wrong again. I hope you can see that. And for this ray, let's have a look. How can this ray go undeviated? Look at this. How can this ray go undeviated? This ray has to deviate because only remember the rays which go from the pole go undeviated. This ray is definitely going to deviate itself. So this is wrong. I hope this is clear. I hope this is clear. Yes, it's a concave lens, not a convex lens. Be careful. Be careful. Is that understood? Everybody understood how to solve this question? Everybody has understood how to solve this question? Yo, cool. Let's get going ahead. So very tricky. Let's see. 1986. By the way, all the questions that I'm asking you today are from PYQs, previous year questions. All the questions. You can see the year number also here. So a converging lens is used to form an image on a screen. When the upper half of the lens is converted by an opaque screen. Okay, the upper half of the lens, you are covering it, or you are covering it with some kind of non-transparent kind of an screen. Then which of the following do you think will be observed? Only half the image will be disappeared, complete image will be formed, intensity of the image will be decreasing, intensity of the image will decrease. I think something is wrong over here. This should have been like same or something like that. I don't know, because both the options C and D look the same to me. So there was, I think, a mistake while typing out here. Okay, come on. Now think about it. Now think about it. Okay. Some of you are saying C, D. Okay. So let me tell you what exactly will happen. So this is our lens. Okay. This is our lens. This is our object. And I don't know, maybe the image is formed over here. Example, this is your image. Now, if you cover this much part with an opaque screen, that means as if this part of the lens is not even there, then a lot of people think, oh, half the lens is gone, so only half the image will be visible. Wrong. Think about it. Why? Because there will be still some rays, okay, which will be going like this or something like this, okay, which will be meeting over there. That means you do not need all the rays to form the image. Only two rays are enough. Just that the rays which used to travel from here and meet here, now they will not be meeting over here. So half the rays will go missing. Only half the rays will meet to form the image. That means what will happen? The intensity of the image will decrease. I hope this is clear. Yes, intensity will decrease and the image will not disappear. It will still be formed. Remember that. So just by covering half the lens, do not expect the image to become half. No, the intensity will become half because half the rays won't meet over there. That's how it is. I hope this is clear. Cool. Well, Jinesh, will I do short series for 11th? You are new to the channel, no problem. So the thing is, Jinesh, I'm doing, I don't know what exactly you mean by short series, but I'm guessing you want like the crisp revision of all the 11th standard chapters. Yes, Jinesh, I have conducted all the chapters revision. In fact, I have taught it, not exactly, you can say it's revision. In fact, I have taught it in a very crisp manner so that you can understand it in a short time and also start applying those concepts in problems. There are only few chapters remaining like waves and sound and maybe thermo, but otherwise everything else has been covered, right from kinematics, projectile, relative, mechanics, SHM, all these topics have been covered. I hope that answers your question. Yes, Ankit, I do teach on subscription. Yes, I do teach on subscription. Okay, so I think I discussed this question right now. Okay, so B and C are correct. Option D. Okay, we are done with this. 1999 question. A concave lens of glass, refractive index 1.5, has both of the same radius of curvature. On immersion in a medium of refractive index 1.75, what will it behave like? Okay, so now let me tell you about the lens formula and all the formulas that you need for lenses. So let's get going with the formula for lenses, guys. So in fact, I can give it to you on another slide so that we can use it over here. So let me give it to you over here. Lens formula. Okay, so what are the formulas for lens? Okay, keep this in mind. 1. The focal length of a lens. Okay, the focal length of a lens is given by mu minus 1 into 1 by R1 minus 1 by R2. This is called as the lens maker formula. Okay, if you know the radii of curvature and if you know the refractive index of the material, this formula will give you the focal length of the lens. In fact, the reciprocal of that. I hope this is clear. I hope this is clear. And this 1 by f is actually the power of the lens. This is the power of a lens. This f is obviously the focal length. Focal length. So you should know this. So for a convex lens, the focal length is positive. So 1 upon a positive number will be positive. So power will be positive. So remember that power is positive for converging lens and it is negative for a diverging lens. Very, very important. You should know this. For converging, power is positive. For diverging, the focal length will be negative. So power will also be negative. I hope this is very, very clear. Narinder, most of the things will be taught on YouTube. I'm not sure what you mean by everything, but yes, almost everything will be taught on YouTube. Yes. Okay. Now, next up over here is the next formula, which is the main lens formula, and that is 1 by V minus 1 by U is equal to 1 by F. This is the next formula that you must know apart from this formula. So what is this formula going to give you? This is image distance, this is object distance, this is the focal length. If you tell me where the object is, I can tell you where the image is. Okay, I hope this is clear. Next up is magnification. Magnification of that object height wise. How much is the magnification? The formula is just similar to the mirrors. It is just V by U. You should know this formula. You should know this formula. Okay. Sonali, it is both for SA as well as SX. And Shreyas, I would love to do it in dark mode, but the problem is the moment I go to dark mode, the way in which my studio is arranged, all the lights will start reflecting and you will not be able to see anything. So that's why. Okay, cool. Next, P means power. Okay, Shreya, P means power. Power of the lens. How diverging or converging the lens is. If it is converging a lot in a very small distance, it has more power. Okay, next up, this magnification is for height. This is height of the image upon height of the object. There is one more magnification formula and you must know that. What is the other magnification formula? This magnification, width-wise. So if there is an object over here, okay, the image might be wider or shorter. So this is the width of that image. So that magnification is what I'm talking about. So that magnification is given by V square by U square, and that is also equal to velocity of image upon velocity of object. Very, very important. So you can see the minus sign is missing. In mirrors, minus sign was there everywhere, including over here. So this was plus actually. So in lens formula, it has become minus. So all the formulas which are there for mirror are still valid here. Just that wherever you saw minus sign, remove it, and wherever you saw plus sign, add a minus. That's all. Okay, I hope this is clear. Yes. Anand, I'll be doing JEE Advanced PYQs after maybe, you know, the first attempt of JEE. First, I want you guys to understand all these concepts at a basic level. There is no point doing advanced question right now. If I do advanced question, half of you are not going to understand it. And you saw that probably in yesterday's lecture, that it is very important to first clear your basics and then go ahead. Is that right, Anand? Okay, so let's get going with the next part. Okay, so this was magnification formula, mirror formula, lens maker formula, sorry, lens formula, lens maker formula. Everything has been done over here. So let's get going with questions now. Let's get going with questions. Okay, and let's see that question right now over here. So 1999 question, there is a concave lens of glass, refractive index is 1.5, both surface have the same radius r. When you immerse it in a medium of refractive index 1.75, it will behave as what? What will it behave as? Let's see. Okay, so first of all, let me draw the diagram so that you get I hope now it's fine. Thank you guys for pointing it out. I just saw the chats, my bad. So this is R1, okay, this is the first surface, and this is R2. I hope now it's fine. And R1 will be negative R and R2 will be positive R. Okay, I hope now it is fine. Cool. And this medium is how much? 1.5, and the outside medium is 1.75. I hope now it's fine. Yes. Okay, chalo, let's get going now. So 1 upon focal length, the focal length of that particular lens will be equal to mu. But this mu will not be the refractive index of the lens. It should always be the relative refractive index. Usually what happens when you write mu minus 1, this mu is the refractive index of the lens, okay, with respect to vacuum. Now outside there is air, and air and vacuum are almost similar, so it is fine. But when you place it in some dense medium like this, then you need to be careful. This mu has to be relative mu. So what I'm going to put over here is refractive index of the lens with respect to the medium minus 1, and you will have 1 by R1 minus 1 by R2. Let's start substituting things. Refractive index of the lens with respect to the medium. Think about it. Lens refractive index is 1.5 and the medium's refractive index is 1.75. Now I have also seen students committing one more mistake here. What they do is they put 1.5 minus 1.75. That is wrong. They think this 1 stands for the refractive index of air. So when the medium changes, what they do is they replace this 1 with 1.75. That is wrong. Please understand this. Okay, so it is 1.5 by 1.75 relative mu, and 1 by R1. What is 1 by R1 over here? It is 1 by minus R minus 1 by R2. What is R2? It is plus R. I hope this is clear. Now 1.5 is nothing but, you know, 3 by 2. I hope this is clear, guys. 1.5 is nothing but 3 by 2, and 1.75. How much is 1.75? It is nothing but 7 by 4, I believe. Just check this out. So minus 1, and this will be nothing but minus 2 by R. Okay, so this 2 and this 2 will go, and it will become 6 by 7. Now 6 by 7 minus 1 is minus 1 by 7. So minus 1 by 7 multiplied by minus 2 by R. That will make it 2 by 7 R. Therefore, I will get focal length, invert it, flip it, I'll get it as 7R by 2. Now look at this number. This 7R by 2, isn't it a positive number? If it is a positive number, what does it mean? The focal length is positive. That means the lens is going to become converging in nature. I hope this is clear. This is going to become converging in nature. So that is very, very important, guys. So this was actually a concave lens, but in air it was diverging, but inside a denser medium it becomes converging. Same thing will also happen with a convex lens. If you take a convex lens, usually it is converging, but the moment you place it in a denser medium, what will happen? It will become diverging in nature. I hope this is clear. Is that understood, everyone? Okay? So we have also found out the focal length. I have told you how to find this out, and we have seen that it is converging. Cool. Let's get going with the next question up here. Yes, it is a converging lens of focal length 7/2, which is 3.5 R. We just figured it out. Okay, cool. Next question up on your screen. There is an image. Okay, there is an image of an illuminated square, and it is obtained on a screen. Okay, with the help of a converging lens. Okay, the distance of the square from the lens is 40 centimeters. Okay, the area of the image is 9 times that of the square. The focal length of the lens is. So let's get the diagram first. Okay, so this is the diagram. So this is the square, and there is a converging lens. The square's image, the red one, is formed on a screen. Okay, and the area of the square is becoming 9 times larger on the image on the screen. The question is, what is the focal length? Let's try to think about it. Now, understand, the square will have some height, some base, etc. Correct? There will be some height of that square. Now, if I tell you the area is 9 times, so area of the image upon area of the object is 9 times that one of the object, then isn't area proportional to or is equal to, height of the image square upon height of the object square? Isn't it? Isn't it? Height of the image square by height of the object square. Now think, illuminated square means it's like a source of light. It's a bright square. That's all you need to understand, Shreyas. Okay. Aman, why did I use the lens maker equation in the previous question? I used it because I wanted to see whether it was having a positive focal length or negative focal length. Because if the focal length is positive, then it is converging. If it is negative, then it is diverging. That's the reason why I used it. I hope it is clear. Okay. Now, if this is true, then think about it. Height of image upon height of object will be 3/1. Now, what is height of image upon height of object? Magnitude wise, if I just take the magnitude, that is nothing but V by U's magnitude is 3/1. That's it. I got it. Because remember, height of image upon height of object is magnification. That magnification is V by U for a lens. I got this. Okay, cool. Now I'll make use of this. I'll make use of this in the lens formula. So let's make use of the lens formula. 1 by V minus 1 by U is equal to 1 by F. Therefore, okay, do I know where the object is? Yes. See, from the lens, the square is at a distance of 40 centimeters. So, object distance, will it not be minus 40? Check this out, it will be minus 40. Focal length, I don't know. Image, well, image by object distance is 3. So, if object distance is 40, image distance should be 40 into 3, which is 120. But be careful, the image is obtained on a screen. That means the image is obtained over here, this side at 120 centimeters. So the value of V will be plus 120. I hope this is clear. That is what you need to be very careful about. Now, what will happen? What will happen? Just solve this properly. So this will be 1 by 40 because minus minus will become plus. Okay, and this will become 1 by F. Therefore, 1 by F will be, so 1 by 40, take LCM guys. So multiplied by 3, numerator and denominator. So it will become 1 plus 3 divided by 120, I believe. 1 plus 3 is 4 and 4 by 120. So this is 4. So just divide it. So it will become 30. So focal length is just 30 centimeters. That is the answer. I hope this is clear. I hope this is clear. Everybody understanding this? Yes. Yes. Correct. Very good. Very good. So this is how you are supposed to solve it. Yes. This is the correct answer. Let's get going with the next series of question. Like I was telling you, for convex lens, the focal length being positive, the power is positive. For a diverging lens, understand the focal length is negative, so power is also negative. Please understand, if the focal point is closer to the lens, like the one here, it has more power. So power is inversely proportional, like I was telling you. The power of the lens is inversely proportional to the focal length. And remember the units, if focal length is in meters, okay, if focal length is in meters, the power is expressed in diopters. So if focal length is 1 meter, the power is 1 diopter. This is what you should know. I hope this is clear. Cool. Let's get going. Now, when you have 2 or more lenses in contact, like this one, you know what you should do? These lenses can be treated like one single lens, guys. Yes. So that you don't have to use the lens formula or any other formula twice. You can convert this. One second. You can convert this into one single lens of effective focal length. And how do you do that? If this lens has focal length f1, this lens has focal length f2, what adds is their powers. So power of that combination is power of lens 1 plus power of lens 2. Power of lens 1 is 1 by f1. Power of the lens 2 is 1 by f2. So power of the combination is given by this effective lens. So it will be 1 upon focal length of the effective thing. That's it. So this is how you can find the effective focal length. And once you get the effective focal length, that's it. If the object was given, you can find where the image is by using your lens formula. That's it. I hope this is clear. Yes. So Jagdish, let me know what question you have. Definitely I'll reply to you. Yes, Raghav, this is for JEE. And yes, this is a JEE English channel for all the JEE aspirants. Yes, this is what it is. Okay, cool. Let's get going. Let's solve this 2007 question, which was asked in JEE. 2 lenses of power minus 15 and plus 15 are in contact with each other. The focal length of their combination is. Come on, let's see how many of you get this. Obviously, Utkarsh, this chapter is in fact very, very important for JEE. Very important. राघव, हम हिंदी में बता सकते हैं, बट हिंदी में बताने के लिए दूसरा एक चैनल है, ये इंग्लिश चैनल है. तो यहाँ पर मेनली हम इंग्लिश में पढ़ाएंगे. सो हिंदी के लिए एक दूसरा चैनल है राघव, यू कैन ज्वाइन इट. ओके. Okay, let's get going and let's see how do we solve this particular question. Now, 2 lenses powers are given, so the effective power will be minus 15 plus 5, so it will become minus 10 diopter. But effective power is 1 by effective focal length, so it will become minus 10. Therefore, effective focal length will become minus 1 by 10. Now I know what you guys are going to do. You guys are going to immediately mark option A, and most of you are also saying that it is option A. Yes, Jagdish, don't worry, I'm not going to use Hindi, but I had to tell in Hindi because that guy was asking in Hindi. So I understand, Jagdish, don't worry. I did not give in some trade secret or anything or a secret formula. Don't get scared, Jagdish, okay? I'm there for you. Yes, so now a lot of you are going to mark this, but that is not the correct answer. Be careful. This is in meters. So this is minus 0.1 meters, but the answers are in centimeters. So hence minus 0.1 meter is nothing but minus 10 centimeter. Hence the correct option is D, and that's why this came in JEE. And many people got it wrong. Imagine doing this mistake in the exam. How bad will you feel? Won't you feel like hitting your head against the wall? I hope this is clear. I hope this is, oh sorry, minus 10. Where is minus 10? This was plus 10, my bad. This is minus 10. Yes, the answer is minus 10. Look at that, look at that. Yes, it will be very, very bad if you commit this mistake where you forget to convert the units. Remember, power is in diopters, focal length is in meters. Be careful about it. Cool, let's get going with the next question. Minus 10 centimeters is the answer. Let's see how to solve this question. 2006 question. Rays of light from the sun fall on a biconvex lens of focal length f, and the circular image of radius r of the sun is formed on the focal plane of the lens. Then, which of the following is true? Which of the following is true? Come on, think. Think about this, think about this. How do we do? Okay, no idea? Don't worry. Forget the options. Let's try and solve this. So imagine a lens. Okay, just imagine a lens. Okay, out here. And then let's try to draw how the ray diagram will look like. Remember, the rays of light from the sun fall on this lens. So rays of light from the sun are almost going to be parallel. And when the rays of light are parallel, what will happen? The image will be formed at the focus. Keep this in mind. So the rays of light, which are going to be almost parallel, okay, from the sun, they are going to form the image at the focal point. So this is the focal point. The rays which pass through the principal focus, remember, they go undeviated. So I've just shown that ray over here. Okay, now let's say this is the pole. Okay, this is the pole. And let's see what else we know. The image of the the circular image has a radius r. That means this is r and this much distance is f. Okay, cool. Then the question is, we have to figure out what is the area of the image proportional to and stuff like that, intensity and stuff like that. Is that right? Okay, so let's see how we solve this question. Now think about it. If I mark, okay, let me mark this angle over here. If I mark this angle as theta, okay, then what is tan theta, guys? Tan theta will be r divided by f. Therefore, think about it, r will be f tan theta. Therefore, area of the image, the area of the image of that sun, remember it is pi r square. So won't it become pi f square tan square theta? Now out of these things, pi is a constant, tan square theta, all these are constants. If all these are constants, what is the area of the image proportional to? Isn't the area proportional to the square of the focal length? Do you see that? It is proportional to the square of the focal length. Yes, that's it. Done. I hope this is clear. That's it. Done. So that is the answer, guys. So let's see. Yes, the area of the image is pi r square and it is directly proportional to s square. That is the correct answer. You can see that. That is option B. So it had basic concepts of geometry, and using trigonometry you get that r is proportional to f. That's all about it. Yes. There were options there, Jagdish. I don't know whether you saw it. There were options like this. Okay? So only B option is correct out of them. Cool. Let's get going. Okay. Now, let's see the next question. 2016 question. A convex lens of focal length 30. Okay. This is that convex lens of focal length 30 and a concave lens of focal length 120 and a plane mirror, this is that plane mirror, are arranged as shown. For an object kept at distance of 60, you can see that this is the object, okay, from the convex lens. The final image formed by the combination is real image somewhere. Real image means the rays will merge at a distance of how much from the concave or convex lens. Let's see how this has to be done. I hope this is clear. Okay, let's try and solve this question. Just have a reading at this particular question and then let's start solving this. Okay, let's go step by step. First, let me take this as my object 1 and that object distance in the first situation is minus 60 centimeters. And let me see where is the image formed because of this lens. Because the image of this lens will be the object for the next lens. And once I know that this guy's image is this guy's object, I can again use lens formula and find where the image is formed, because that image will be the object for the mirror. So you have to go sequentially. That's how we need to do this. Let's see how we can do this particular question. So now first use lens formula. So 1 by V1 minus 1 by U1 is equal to 1 by focal length. What is the focal length? Focal length is 30 for the convex lens, I believe. Yes. So it is plus 30 over here. So therefore 1 by V1 will be 1 by 30. Minus minus is plus, shifted there, it will become minus. So it will become minus 1 by 60. So 2 minus 1 by 60. Therefore V1 will become, 2 minus 1 is 1. V1 will become 60 centimeters. I hope this is clear. V1 will become 60 centimeters. So where is 60 centimeters? Well, this is 20. So 60 will be, I don't know, somewhere there. Okay. So somewhere over here. So this is basically image 1. Image 1 because of this lens. This image will now become, think about it, this image will now become object for the second lens. Yes, the object is ahead of it. It's a virtual object. Think of it that way. Let's figure out where the image will be. But before that, okay, before that, think about it. If this much distance is 60 centimeters, for this lens, how much will be that distance? I think that object distance, think about it, 60 minus 20, that is 40. So that should be 40 centimeters. I hope this is clear. Yes, yes, I hope this is clear. Now let's again use the lens formula. So 1 by V2 minus 1 by plus 40. Be careful. Why plus 40? Because it is on the positive side of this lens. This is my second lens. Okay, is equal to 1 by, what is the focal length? 120. So therefore 1 by V2 will be equal to 1 by 120 plus 1 by 40, I believe. I hope this is correct. Everyone is clear about this. Oh, but this is a concave lens, so be careful. So this focal length will be negative. So that's the catch. Because this is a concave lens, so focal length will be negative, so minus 120. So now let's solve this problem. So minus 1 plus 4 3s are 12. So minus 1 plus 3 divided by 120, I suppose. So then minus 1 plus 3 will become plus 2. So this will give you V2 as 120 by 2 is 60. So 60 centimeters again. Just check this out. Is V2 coming out to be 60 centimeters? I hope this is clear. Just check. Everybody has understood this? Now, if V2 is 60 centimeters, think where will the image be formed? Okay. Now, this is 70, this is 20. So, this remaining part is 40 centimeters. This remaining part. So, 60 means it will be here. This distance will be 20 centimeters. So this is where the image is formed. I hope this is clear. This is where the image is formed. Now comes the last part and the trickiest part. Now, here is the thing. This is going to be an object for the mirror. But you will be like, sir, how can the object be behind the mirror? Well, it's possible. It's a virtual object. That means, I'll tell you what. This is the mirror. The rays are coming like this. They are merging here, but they'll get reflected and fall over here like this. So in this problem, this is 20 centimeter. This is basically your object 3. So actually, where will the image be formed? The image will be formed here in front of the screen at 20 centimeters. So the final image will be formed over here somewhere. So this is your I3. This is going to be in front of it, and that will be real image. I hope this is clear. This is the real image. I hope this is clear. I hope this is clear. Is that understood? Is that understood, everyone? So this is the final answer. This is the final answer. That's it. We got it. So you can measure. If the question asks from convex lens, how much is the distance? You can get it. So 20 plus, I don't know, 20, 60 centimeters. From concave lens, it will be, I think, 20 centimeters. So you can get all the distances, and let's see, that should be the correct answer. Yes, 60 centimeters from the concave lens. I think this is wrong. This should have been convex lens. It should not be here. This should not be concave, guys. This should have been convex lens. This is wrong. Okay, so It should have been concave lens. Cool. Convex lens, my bad. I hope this is fine. Cool. Let's get going with the next question then. Let's get going. Now, silvering of a lens related questions. Let's do this. Let's do this. Silvering of a lens. Now, for silvering of a lens related question, what we need to do is that, remember, when you have a lens and a mirror, their combination always behaves like a mirror. Remember this. When you have a lens and when you have a mirror, their combination always behaves like a mirror. So try to convert it into a mirror, that's all. So just imagine, let's say for example, this is a plano-convex lens and the flat surface is silvered. You know what you should do? Think about it. What will this mirror try to do? It will reflect whatever is there in the front behind it. So you will see a convex lens like this. Plano-convex lens like this on this side. Now you forget the mirror, because what did the mirror do? Whatever was there in the front, it reflected it. Right? So it's as if there is a complete convex lens over here. Yes, there's a complete convex lens over here if you ignore the mirror. Now you know how to solve the problem if the mirror was not there, isn't it? If the mirror was not there and it was just a convex lens, if object is given, you know how to find where the image is using the lens formula. So you'll use 1 by V minus 1 by U is equal to 1 by F. U is known, F is known. V you can find out. Once you find the image, be careful of one thing. Wherever the image is, just reflect it back to its original position over here on this side. Because remember, we had opened that diagram. So wherever the image comes, just reflect it back over here. That is where the actual image will be formed. I hope this is clear. I hope this is clear. Yes? Is this understood, everyone? Is this understood? Yes, these type of questions, Lipika, will also come in KVPY. Kirito, after merging two lenses together, whether do we take the position of the lens, effective lens? Kirito, the thing is, when you combine two lenses together, it's very important that the lenses should be sticking to each other and they should be thin lenses. If they are fat lenses separated by some distance, then you cannot use that power addition formula. So this only works when they are close to each other. So that's the reason why in the previous question, I did not take their effective focal length. I hope this is clear. Okay. And I guess any other doubt? I think it should be solved. Yes, Narinder, please make a video on how to make notes for JEE aspirants like you made for NEET aspirants. Narinder, in fact, I had made a video, but not a special video for making notes, but in some another video, like how to score more than 200 marks. And you know, there was some more videos where I have spoken about how to make notes. But still, if you want to understand how to make notes, please get in touch with me on Instagram. I'll definitely help you out, beta. Don't worry if you still want to learn about it. Don't worry about it. Okay? I hope this is clear, guys. Snacks time, thoda sa. Snacks kha lete. What say? So what are you guys eating? I'm eating chips. I'm eating chips. Yeah, snack time. No snacks? Oh, why is that so? Chana, Dinesh is having chana, Yalini is having laddu, Prince is just smiling. What about others? Oh, and I got some Monaco biscuits too. I don't know how many of you love this Monaco biscuits. Oh, some of you forgot that it was a marathon. Banana chips. Oh, I love banana chips. No problem, Shreyas, even if you did not understand single word, happens sometimes. Because I thought that a lot of 10th standard students also understood all the lectures which I made, but it happens sometimes, Shreyas Paliwal. So I would advise, please watch them again. Maybe you'll understand it. Yeah, after maybe the second or the third attempt. So also you can read through NCERT and then you can go through HC Verma So build up your basics. So once your basics become little bit clear, and maybe you start revising it again and again, you put in that 100% effort, for sure beta you will understand it. No Shreyas does not mean you are dull. No, who said that? You are saying that. I never said that you are dull. It sometimes happens that a topic might just scare you and you might just get frightened and you do not understand something. It's okay, perfectly happens. Okay? So I just made the lectures in a very simple manner. Happens. So no problem. Give it a second thought. Oh, Tanmay, it was not mentioned. Acha beta, no problem. But most of the Fridays is going to be marathon. Kirito has finally got some cookies. Looks like you have asked your mom or brother or sister, please give me some cookies. Everybody is having something. Yes, Mahadev, it will be also helpful for KVPY essay because optics is there in KVPY essay also. Okay. Let's begin then. Very true, Jay. Very true. I should call you Bhai, Chota Bhai. And maybe I'm like the Bada Bhai. Murku, VK channel, I love Murkus, yaar. Oh, it's so nice. I know it's very famous in South India. Well, is something alphabets. I will definitely include 2020 questions. In fact, I have covered 2020 questions in a separate video. In fact, we are going to do it like mock test series. So please visit those separate videos for 2020 JEE Mains question. Okay, so we'll be having discussion sessions called as PYQ series. In that, we'll definitely do that. Okay, let's get going then. Let's solve this 2015 question. A thin convex lens of certain focal length is put on a plane mirror as shown in the figure. Okay, when an object is kept at a distance a from the combination, okay, the image is formed at a distance of a/3 in front of the combination. What is the value of a? That's the question. Let's see how do we solve this. First things first. Since there is a mirror, what we can do, whatever is there in the front, open it up. You know? So if there is a lens in the front, so there is a lens behind also. So forget the mirror. Now there are two lenses and these two lenses are going to behave like one single lens. Okay, each length has a focal length. I do not know. In fact, yes, f. Okay, their focal length is f. So their effective combination will be behaving like one single lens. Next, where is the object? Object is at a distance of a from the combination. So my object is over here and this distance is a. Okay, where is the image formed? Well, the image is formed at a distance of a/3 in front of the combination. That means actual image will be formed here, but since I'm opening it up, remember I'm opening it up, so the image will be formed over here. So this is where the image is formed, but actually when I close it back, it will be formed over here, and this distance is given to be a/3. I hope this is clear. Just check this out. Just check this out. Everybody understanding this particular concept? Yes, everyone clear? Cool. Now let's try to figure out what is the effective focal length of this combination. So I will use this. 1 by f effective is 1 by f plus 1 by f. So it will become 2 by f. Therefore, f effective is actually f by 2. Okay, so I found out the effective focal length. It is actually f by 2. Next up, I'll use the lens formula. So 1 by v minus 1 by u is equal to 1 by f effective. Cool. Therefore, what is 1 by v? So v is image distance and it will be plus a/3. Be careful now. The sign conventions have changed. this is the positive side, this is the negative side, because the rays will come from that side. Remember, the rays will be coming from here. So this will be positive, that will be negative. So image is at the positive side. So it will be plus a by 3 minus 1 by u. What is u? U is minus a. It's on the negative side. So minus a is 1 by f effective. F effective is f divided by 2. Cool. So now let's solve this. I don't need this anymore. Okay. So this will become 3 divided by a. Minus minus will become plus. So 1 by a is equal to 2 divided by f. 3 plus 1 is 4. So 4 divided by a is 2 by f. Okay. I don't need this anymore. I don't need this anymore. Okay. 2 gets cancelled. So 2 by a is equal to 1 by f. Therefore, a is equal to 2f. That is the final answer. I've got the answer. F is a by 2 or a is equal to 2f. That's it. I hope this is clear. Is that understood, everyone? Just check this out. Okay? So we have got the answer. The main concept was, because there was a mirror, open it, number 1. And since it was mentioned that the image is formed here, so when you open it, because of that mirror, make sure that the image is formed over here. So if you miss that, you will probably get a wrong answer. That's how this needs to be solved. Very good, very good. Manat, actually no also and yes also. Don't worry about who is more difficult or who is more easy. See, I'll tell you one thing. If you go into this is more difficult, this is easy, you will just be comparing exams. You will not actually sit and study. That's one thing. Second thing, see, the concepts are going to be same. The application might be more complex. So understand, once you go from basics and slowly increase your difficulty level, you will be able to crack all the exams. Number 3, all those students who have cracked JEE Advanced exam have also cleared KVPY, have also cleared mains, not just with normal marks, but also with really great marks. It rarely happens that a person only scores in KVPY and does not score in advanced or does not score at all in mains. So understand, it's not independent. All these are dependent things. If you do well in one exam, you also do well in the other exam, third exam, fourth exam. So you don't have to specially prepare for KVPY or for bits or for JEE. Understand that. This is how it works. Okay, cool. Let's get going with the next question, and here it comes. Let's see how to solve this. Let's see how to solve this. So 1980 question, but beautiful question. There is an object which is placed 21 centimeters in front of a concave mirror of radius of curvature 10 centimeters. A glass slab of thickness 3 centimeters and refractive index 1.5 is placed close to the mirror, and the space between the object, in between the space between the object and the mirror. Okay. Find the position of the final image formed. Okay. The distance of the nearest surface of the slab, that means this one, from the mirror is 1 centimeter. So this distance is 1 centimeter. So let me mark that because I might need it. Okay. So this distance is given to be 1 centimeter. Okay, cool. Now, first of all, the object actually is placed at how much distance? 21 centimeter. Now, first let me get rid of this glass slab. Do you remember what does a glass slab do? It just shifts the image, right? That's all. So imagine for this concave mirror, when you look at this object is going to appear closer to the mirror. Why? Because this slab is going to shift everything which is there on that side towards itself. So there will be some shift and we can calculate that shift. It's not that difficult. The shift due to the slab, remember there was a formula. Recollect what was that formula? It was thickness into 1 minus 1 by mu. Check this out. Do you remember this formula? I hope this is clear. Thickness into 1 minus 1 by mu. Yes. Now, let's do this. What is the formula? Sorry, what is the thickness given? Thickness is 3. 1 minus 1 by mu. What is mu? Mu is, where is mu? Is it given somewhere? Yes, 1.5. This is the refractive index. 1.5, that means 3 by 2. Okay, so it will become 2 by 3. 1 minus 2 by 3 is 1 by 3. So 3 into 1 by 3 will make it 1 centimeter. Okay, so the shift will be 1 centimeter. That means this object is going to shift here by 1 centimeter. So the mirror will perceive the object to be over here. Actually, it will perceive it to be here. Correct. Now, once you have understood this, let's use the mirror formula. Now for the mirror, where exactly, oh, 1 second, the 21 centimeters in front of the concave mirror. So this is not 21, guys. I think this whole thing is 21. This whole thing is 21 in front of the concave mirror. Look at that. The object is 21 centimeters in front of the concave mirror. Cool. So what is the actual object distance? What is the actual object distance? I feel it is just minus 20 centimeters. Just check this out. Yes. I hope this is clear. This is just 20 centimeters in front of the mirror. Okay. Now focal length. Do I know the focal length of that mirror? Well, radius is given. Remember, R is 2f, f is R by 2. So radius of curvature is 10 divided by 2. But it is a concave mirror. So I think it should be negative. Just check this out. So hence the focal length will be minus 5 centimeters because the radius of curvature is given to be 10 centimeters. Now let's use mirror formula. 1 by V plus 1 by U is 1 by F. Let's solve this. 1 by V plus U is 1 by, U is minus 20 and focal length is minus 5. Now solving it further, take this guy over there. So it will become minus 1 by 5 plus 1 by 20. Now solving it further by taking LCM. So multiply by 4, numerator and denominator. So you will get 1 by V is minus 4. Correct? Plus 1 divided by 20. So this will become minus 4 plus 1 is minus 3 by 20. Therefore, V you will get it as minus 20 by 3, which is, minus 6.67 centimeters. Okay, so this is the value of image I got. I don't need all these things. I'll get rid of this. I don't need this. Okay, now what does this mean? This means the image by the mirror will be formed somewhere over here. But remember one thing, this glass slab won't allow it to do so. The image won't be exactly formed here. The image will also shift actually by 1 centimeter because of the glass slab. The rays coming from the concave mirror will get deviated and you will see that they will merge a little bit ahead. That is the problem. So hence the final image from the concave mirror, okay, the final image from the concave mirror will be this distance 6.67, which is from here till here, plus that one. So that will be 7.67 centimeters on this side. I hope this is clear. Yes, very, very important. Correct. So Akshat, see, every day we come here at the same time. So make up a timetable. At this time I'm going to do this. At this time I'm going to chill out. So remember, distractions can be avoided if you manage time. If you have a fixed schedule, at this time I'm going to study, at this time I'm going to enjoy. So when you do both enjoyment as well as work and studies, then you will not get distracted, you will be focused. And number 2, you should be clear why you want to do engineering, why you want to crack IIT exam. Believe me, once you have that in your mind, you will never be distracted. Yes. Very good. Let's get going to the next question. So yes, this was the answer, 7.67. Let's do the next question. 2019 question. Very, very interesting question. Let's see how do we do this. There is a plano-convex lens of focal length f2. Okay. Refractive index mu2. radius of curvature r, plano-convex, visualize it, fits exactly into a plano-concave lens. Imagine plano-convex fits exactly into plano-concave. Together, what will they behave like? Like a glass slab. But not exactly a glass slab, because the problem is refractive indices are different. Can you see that? Refractive indices are different. So, you know, they will not cancel out each other. Be careful. Be careful. Be careful. Okay. The question is, what is the effective focal length of the combination? These are the options given. Let's try and solve this. But for that, let's figure out the diagram first. This is how the diagram is going to look like. You can see there is a plano-concave lens, and on this side there is a plano-convex lens. Now let's see how do we solve this. First, let's figure out what is the focal length of the concave lens, then figure out the focal length of the convex lens. Since they are in contact, I can find the effective focal length by the power formula. So first I'll find f1 and f2. So how do I find f1 and f2? Okay, concentrate all your attention on this lens first. This is your first surface, this is your second surface. So the radius of curvature of the first surface is infinity. Yes, it's a flat surface. The radius of curvature of this surface, that is r. So my first focal length f1 is going to be mu. Is it concave? Plano-concave lens has a focal length f1. Refractive index mu1. Okay. So mu1 minus 1 into 1 by, this is infinity, minus 1 by, that radius is positive, so plus r. Okay. So I'll get this as mu1 minus 1 divided by minus r. That is what I'm going to get. So this is the value of 1 by f1. Is that clear? That is the value of 1 by f1. Now, if this is understood, let's try to figure out the next part. And here it is. This is this plano-convex lens. Now think about it. Now think about it. This is the first surface. This is the second surface. This is the radius of curvature 1. And the second radius of curvature is infinity because it's a plane surface. So let's do this again. 1 by f2 will be, okay, mu2, because that's the refractive index, minus 1 to 1 by, think about it, r1 is plus r1, plus r, sorry, minus 1 by, okay, minus 1 by, think about it, what is the second radius of curvature? That is infinity. So guys, what are you going to get 1 by f2 as? You're going to get it as mu2 minus 1 divided by r. Isn't that right? Isn't that right? Okay, now what is the last step remaining? Add them to get the effective focal length. So 1 by f effective is 1 by f1 plus 1 by f2. So mentally add this, or if you want, you just add it as it is like that over here. 1 by f1 is this value. So minus mu2 minus 1 divided by r. Okay, minus mu1 minus 1 divided by r plus this is mu1, my bad, mu1 plus mu2 minus 1 divided by r. That's what I'll get. I don't need this anymore. I'll just erase this. So guys, what will this give me? 1 by f effective is going to be equal to minus mu1, minus minus will become plus. Because denominator is common, I can just add them. So plus mu2 minus 1 divided by r. So this will become mu2 minus mu1 divided by r. So effective focal length will be r divided by mu2 minus mu1. That's the answer. Correct. I hope this is clear. I hope this is clear. No problem, Achut. You have missed a lot, by the way, today. Those of you who are joining in late, you have missed a lot. And guys, I hope you have already liked and subscribed the video. If you have not done it yet, please do that in case you have forgotten to do that. Yes, that's the answer. That's the answer. So, like we just saw, that is the answer. A lot of people thought the answer will be 0 or something like that, you know, because a concave and convex lens will cancel out each other. But the catch over here is refractive indices are different. So that's the main problem. Okay, so Are you guys now ready to start with prisms? Most important formulas for prisms. That's what I'm going to give you guys. Are you guys ready? Ready, guys? Yeah? How many of you have seen this prism? Anytime? Have you seen this prism anytime? Ready-o? Very good. Very good, very good, very good, very good. Wow, nice rainbows out there. So let's do this. Let's do this. Let's do this. Okay, Princey. Princey needs rest. Kya baat hai? Chalo, Princey, it's going to be short. Half an hour more and I'm done. Okay, chalo, let's do this. Now, when white light is passed through a prism, you will see all the colors of a rainbow. My question to you is, white is made of how many colors? White color is made of how many colors? And I know you are going to answer, sir, obviously, come on. Violet, indigo, blue, green, yellow, orange, red. So 7 colors. Wrong. That's wrong. White light is made of infinite colors, ranging from violet to red. Understand, it's not 7. There are more colors. There are more shades. Do you think there are exactly 7 wavelengths? No, there are infinite wavelengths. So it's wrong to say it is made of 7 colors. You can say 7 distinguishable colors. That's okay, but it is not exactly 7 colors. Please understand that. Albert, mere bacche, what is that? Please stop spamming, Albert. Kya problem hai? You are such a nice student, Albert. Why do you want, I know you want me to respond to you. It's okay, happens. But bacche, please stay cool, hai na? Don't worry, I'm going to give equal attention to everyone. So you don't have to crave for that attention. I'll do it for you. Don't worry, I'm going to respond to all your doubts. Yes. No, I did not get hurt. I just feel ki what happens? Why do you suddenly come and spam? Okay? And you are such a nice student, Albert, Achut. I know you are a nice student. So please don't do that. Okay? You are a very regular minion and you have been following this channel so regularly. Hai na? Chalo, let's do this. Now, most important formulas in lenses. Let's do this, guys. I'm going to give you all the important formulas. So when a light is incident over here, this first angle, there are 4 angles, by the way. This first angle, I'm going to call it I1. I don't know whether it is seen. I'll mark it in red if needed. So this is I1. Then this angle, I'm going to call it R1. This angle, R2. And this final angle, I2. This is how they are labeled. If light comes from here, this I1 is called as the angle of incidence. This angle I2, which comes over here, that is called as the angle of emergence, because the light ray is emerging from there. And this angle A is called as the angle of the prism. Okay? That's very important. That's called as the angle of prism. Snell's law is obeyed here also and here also. If you draw normals, you can see Snell's law will be obeyed. That means sine of I1 divided by sine of R1 will be refractive index of the prism material. Also over here, understand, I can go reverse and I can say sine of I2 divided by sine of R2 will be also mu. So this relationship holds true. You will be needing it for solving problems. I hope this is clear. Hello Aditya Singh. Okay, now next up, the most important formula. This angle of the prism is always equal to R1 plus R2. It can be proved via geometry. So remember all these formulas. Very, very important. Who is what? Okay? I hope this is clear. Come on guys, focus on the session. Come on. Don't worry. Hello Muskan, join in. Okay, let's get going to the next part of this. Again, a very important formula that I'm going to give you now. So if you have an incident ray, oh, by the way, I just remembered, okay, some of you might be saying, sir, this is incident, that is emergent. So what if the light comes from here and it goes here? Well, don't worry, this will be called incident, this will be called emergent. They are reversible, okay? Because light can travel like that or like that, it will take the same path. So it depends how the light is entering and from which face is the light emerging. Okay, now the light which entered here is going to bend first surface, bend at this next surface. So finally, it's going to go in that direction. The original intention of the ray was to go in this direction. So you can see the light ray has deviated, and this is the angle of deviation. You can see that. This is the angle of deviation. So this delta, you should know the formula. How many of you know that formula? Is I1 plus I2 minus A. Very important formula again. This will depend on I1, I2, etc. Okay? If you change the angle of incidence, obviously the emergent ray will also deviate and this delta will also change. So very important formula. Correct. Incident plus emergent minus A. Very important formula. So let's begin with some problems now. Let's see how many of you get this. 2018 question. A ray of light is incident at 60 degrees on one face and the prism angle is 30. Emergent ray makes an angle of 30 with the incident ray. Be careful. The angle made by the emergent ray with the second face of the prism will be 30, 90, 0 or 45. Let's start solving this particular question. So, what and all is given? A ray of light is incident at an angle of 60. I1 is 60 degrees. Next, angle of prism is 30. So, A is 30 degrees. Okay, A is 30 degrees. It's given. 60 degrees also taken care of. Emergent ray makes 30 degrees with incident ray. What is that 30 degrees? Can you guys tell me what is this 30 degrees exactly? I2, R1, R3, R2, I3, I4, delta. What do you think it is? Come on. Think about it. No problem, VK. Is it I2, delta? What else is it? Guys, this is incident, it bends and finally emerges. This is incident, this is emergent. This angle is delta. Angle which the emergent ray makes with the incident ray. So be careful. Yes, that 30 degrees is actually delta. Many people did not figure this out in the examination in 2018. Yes, I hope now it is clear. Now, if that is clear, okay, now we can use our formula, guys. Remember, delta was I1 plus I2 minus A. Let's use this. Delta is 30. Now, let me tell you guys, the problem is not over. You will see one beautiful thing and you will bang your head against the wall or probably the table after I solve this question. And I'll tell you why. Okay, I1 is equal to 60 degrees. I2, I don't know. In fact, I have to find that out. Minus angle of prism is 30. Okay, so that's about it. So therefore I2 will be nothing but 30 minus 60 plus 30. Oh, interesting, it's becoming 0 degrees. I2 is 0 degrees. So I know what you guys are going to do. You're going to mark this, right? You're going to mark this. Be careful. This is not the correct answer. This is the correct answer. You know why? Because the question is with the face of the prism. That's what they have asked. That is the catch. A lot of people did not remember or misinterpreted the question. So if this is the normal, okay, always the angles are measured with the normal. If the angle with the normal is 0 degrees, that means the ray is coming like this. So with the face, what angle does it make? 90 degrees. Is that clear, everyone? Is that clear? Shreya, in fact, I did that. Monday, I conducted one class, Shreya, entire KVPY essay formulas, you know, in Monday's class. So please watch it. Interesting? Cool? Let's get going. Very good, very good, very good. Chalo, let's get going. Guys, come on, go hit the subscribe and the like button if you have not done it yet. If you have not done it yet. No, Dinesh, I won't want to do that. I am not so mean. I said you can go bang your head against the wall, but because you would probably do this mistake, most likely. But anyways, so that's the answer. Let's get going to the next question. 2013 question. The graph between angle of deviation and angle of incidence for a triangular prism is represented by which of the following? This is easy one. You should be able to do this. Anurag, yes, it is compulsory to subscribe. You have to. Or else I'm going to come with a stick and run behind you. Come on, think about it. Shreya, everything is important. If you want to clear KVPI, there is nothing like not important. KVPI cutoffs are very good, and plus, if you want to clear the second round, because KVPI means the selections are hardly anything. So everybody gets a really good score if you want to clear KVPI. So there is nothing like important and not important topics. ठीक है? Very good, Anurag. क्या बात है? Good. Hello, Vijay. Okay, a lot of you are saying C, D, B. Guys, simple. This is the graph. Don't you know that there is one angle for which the deviation is minimum? Yes. For all other angles of incidences, the deviation is not least. Only for one angle, the deviation is least, and that's why the graph looks like this. You should know this. Okay. So cool. Yes. So now let's see the formula for minimum deviation. Now, talking about minimum deviation, the angle of minimum deviation, that's what I'm interested in now. So the graph of deviation versus angle of incidence looks almost like this, and at one particular angle you will see the incident angle is such that the deviation is minimum. Now when that happens, this is very important, guys, very important. So let me show the diagram, in fact, over here. Yes, when that happens, the entire diagram is symmetric. Keep this in mind, lock it in your head. I1 is equal to I2, R1 is equal to R2 at delta minimum. When delta is minimum, it is entirely symmetric. These two angles are same, these two angles are also same. Very important. Now there is another formula which you should know. Mu is sine of angle of prism plus the minimum deviation by 2 divided by sine of A divided by 2. This is the other formula. So remember, if mu is given, A is given, you can find a delta using this complex formula. But this is very important for solving problems. I hope this is clear. Okay? So yes, very fancy formula. You should know this, but I hope you have written it down in your notes. I'm giving a question in front of your screen right now. Get ready. Here it is. 2019 question. A monochromatic light is incident at a certain angle on an equilateral triangular prism and suffers minimum deviation. Okay, the refractive index is √3, then the angle of incidence is, let's see how many of you can solve this. Kirito, it comes a parabola via derivation, not otherwise. Okay, it comes out to be a parabola. Okay, chalo, let's start solving this now. Okay, let's see what and all we know. Okay, let's see what and all we know. So options are there over here, but let me remove these options. Oops, I don't want to show the answer. Oh my god. Okay, so let's start solving this. Refractive index is given. Okay, so let me use this formula. Mu is sine of A plus delta minimum by 2 divided by sine of A by 2. Mu is √3. Okay, sine of equilateral triangle. That means angle of prism is 60 degrees. So 60 plus delta minimum by 2 divided by sine of 60 by 2. Now take this over here. What will you get? Sine 60 by 2. 60 by 2 is 30. Sine 30 is half. So you will get this as √3 by 2 is equal to this term, which is sine of 60 plus delta minimum by 2. Okay. Whose sine is √3 by 2? Whose sine? 60 degrees. Correct? So whatever is there inside of it, which is 60 plus delta m by 2, that must be 60 degrees. Therefore, 60 plus delta m must be 120 degrees. Therefore, delta minimum must be 60 degrees. Is that clear? I hope this is clear. Now, since you have got till here, now the problem is not yet done. Why is the problem not yet done? Because the question is angle of incidence has been asked. Now for that, use this formula. Delta is I1 plus I2 minus A. When the deviation is minimum, which is 60 degrees, then I1, I2 are equal. Remember, I just told you. So it will just become 2I1 because it is least deviation. Minus A, okay. But angle of prism, equilateral. So 60 degrees. So 60 goes there. So 60 plus 60 is 2I1. Therefore 2I1 is 120. Therefore I1 is 60 degrees. So C option should be correct. Many 60s are there, I know. Correct. I hope this is clear. Yes. I hope you understood how to use these formulas for prism. After this, you are not going to face challenges, so many challenges, because you have solved actual questions. Guys, today's entire session contained all previous year questions. So I gave you the theory, made you solve problems. Gave you the theory, made you solve the problems. That's what we have done. Next question coming up on your screen. But before that, the last topic for today, and that is thin prisms. Anurag, you cannot cover 6,000 questions, my dear kid, in 2 months. Not possible. Not possible. I'm telling you why. If you do 6, unless those are very easy questions, lallu questions, yes, possible, but otherwise it is not possible. Okay? Understand, I cleared my JEE. Many of my students cleared JEE, not because they solved many thousands of questions. No. In fact, there are some students of mine who just solved HC Verma, who just solved the coaching material, and who just solved probably the previous year's questions. That's all. Previous year's questions, HC Verma, and coaching material, and obviously coaching from us. More than enough, and they have got 2-digit All India rank. I'm not kidding, I'm not joking, I'm not making this up. That's how it is. So you don't have to solve so many questions, just solve via understanding. See how it is done by yourself. Try to analyze the questions, solve from the good books, that's enough. Solve from previous year's coaching material and attend these classes, that's it. I don't know which coaching material, Hanura, but see, the thing is, you don't have to solve all the coaching material problems. You have to select wisely. So what happens in our Tattva module, all right, in Vedantu, there are difficulty wise, there are a lot of problems. So I tell my kids, once you have got the hang of easy problems, then go to the next level of problems. Don't have to solve everything. Once you get the hang of next level of problems, go to the next type of questions. And you know, the questions have been beautifully arranged in the Tattva module. So you know that, okay, now that I understand this concept, so I don't have to solve many more questions on this. I can skip and go to the next concept. That's how it is. That's how it is. Oh my God. Okay. So Narendra, my rank was 3,900 when I wrote my JEE, that is in advanced, and my physics marks were almost full. So I love physics, and that's how I am here. Okay. So some of you probably took some time to interpret that this is a prism. I hope, guys, I have answered all your doubts. Yes, Anurag. Yes, Narendra. All right. Pretty cool. Hello, Aman Multani. Oh, you're my student. Great. Chalo, let's get going. Yes, this is a thin prism. Now, when the prism is thin, what does it mean? This angle is very small. This angle is very small. So this A is very small, guys. So what will happen? Mu, which is sine of A plus delta m by 2 divided by sine of A by 2. When angle is small, whatever is there inside of it becomes the sine of that. Remember, sine theta is theta when theta is small. So this will become A plus delta m by 2, whole thing divided by A by 2. 2 cancels. So you will just have A plus delta m divided by A. Now shift that a over here, so it will become mu a is equal to a plus delta m, correct? So delta m will become mu a minus a. So eventually what I'm going to get, delta m is equal to a into mu minus 1. This is the formula. But okay, so when you know the angles are very small, this angles are very small, only then this is going to hold true. Now I'll tell you something which most of the probably channels or teachers would tell you. So here is the thing, when the angle is large, the graph of delta versus I comes out to be like this. When the angle is large, the graph of angle of deviation versus incidence comes out to be like this. But when the angle is very small, the graph comes out like this. It's almost the same. It's hardly going to be anything. So delta minimum, delta everything is almost the same, guys. So instead of putting delta m, I'm just going to put delta over here. I hope this is clear, guys. So the delta minimum, delta is almost the same for thin prisms. I hope this is clear. So Naithru, I'm not sure you joined the lecture now. So don't worry, watch the remaining part. You can watch the replays. So that's the best part about YouTube. If by chance you miss anything, you can watch the replays, bacha. And remember, try to attend these classes regularly so that we can prepare you well for JEE Mains, Advanced, KVPY, all the exams that you are going to give. Okay? Yes, smiling graph. So remember this formula. Delta is a into mu minus 1. Very important. Now we will talk about dispersion of light. Such a beautiful looking diagram. Somebody was asking me, sir, why don't you use dark mode? Now do you see why I don't use dark mode? You can see all my reflections out here. All right. So all the lights, studio lights out here. So that's the reason, guys. Yes. So Naithru, also let me tell you, if you still have doubts, you can ping me on Instagram, or you can post your doubts, like many students, many minions out here do that. They post their doubts or any suggestions or anything that you feel like in the comment section, and I have been very regularly answering all your queries, whatever, whenever I can find time, I do that in the comments after the video is over. Okay. So Vijay, all I said was, usually when angle of the prism is large, the graph is a nice U-shaped like curve. But when the angle of incidence is small, it is U-shaped, but the U widens. So there is hardly any change for delta. So delta minimum is approximately same as delta. Okay, cool. So yes, cool. Now, since many of you, some of you are also asking, sir, what if I have more doubts? How do I get it answered? So guys, if you have doubts in your JEE or CBSE, the best thing, guys, to do is actually enroll into the crash course. See, let me tell you one thing. Some of you keep asking me, sir, what is the need of crash course when I'm attending your lectures on YouTube? Can I not crack the JEE exam just by watching YouTube lectures? Yes, you can. Yes, definitely you can. I'm telling you. Then you'll be like, sir, why are you saying that to join the crash course? Should I waste my money? No. See, guys, not everybody can be so systematic that every day you actually motivate yourself, attend the YouTube lectures, and you actually practice tests on your own, analyze and try to figure out what went wrong, and then think, oh, this question was done this way, why I didn't do it that way? Or if you don't understand something, or if you have some conceptual misconception, then how this has to be done, then referring multiple books, referring multiple sites, all this work has to be done by you. Now, all this work can be offloaded to teachers, teacher in the class, doubt solving teachers who are experienced and who will solve your doubts. So you don't have to go through that path, because remember, I am telling you now, you can crack the JEE exam even without the crash course. Yes, you can. But not everybody will be able to self-motivate themselves, will be able to refer to multiple books, understand what they are doing wrong, and also that competition that you get among different students, that won't come. Also, what about test series and getting your all India rank? So understand, YouTube plus crash course can work like a marvelous combination to get really good marks. That is why I'm telling you. I hope this is clear. Yes. So guys, yes, some of you had some. No, today's session is not over. There is one last thing I have to tell. So I know a lot of you are thinking, oh, sir is talking about the crash course, so the lecture is over. No, it's not yet over. It's not yet over. So there are some more things to be told. So guys, get all these 45 JEE sessions and 107 CBSE related sessions in this crash course. It's a special crash course. The JEE sessions were there in the normal crash course. We have added these CBSE sessions. If you would love to, please go ahead and check them out. And guys, remember, in the sessions there are two teachers. One main teacher, master teacher, and class teachers to assist you with your live doubts, so that anytime you face some difficulty, like in YouTube at least what happens, we have a lovely family of minions. So think, a lovely family of minions is replaced by a class teacher who is constantly responding to all your doubts. So same thing happens over there also. I hope this is clear. Yes. Have I taught more concepts on YouTube than on Vedantu Pro? Very good question, Ananjan. So let me tell you, if I teach Newton's law, okay, if I teach Newton's law on YouTube, then I will write like this. Newton's law, F is equal to mass into acceleration, okay, on YouTube. But if I teach Newton's second law on Vedantu Pro, okay, then I will teach it like this. Net force is equal to mass into acceleration. So this is the difference. I hope you see that. I hope you see that. Okay? So any more doubts if you guys have, please let me know. Please let me know. Nothing? Okay, cool. Let's get going to the next concept. And by the way, let me tell you, the link for joining the crash course is there below. Please check it out, and you can avail the discount by using the discount coupon SHCC21. That's how it is. Yes. Cool. Let's get going. Let's get going. Let's get going. Let's get going. Chalo. Now, dispersion in thin prisms. So just like I was saying, guys, see, the difference in pro subscription and the difference on YouTube is that, you know, you will get the same content. You will get the same teachers. The thing is, you will get additional benefits of doubts. You will get the additional benefit of the coaching material, that material, masala. You will get that hard copy. Yes. Plus, you will have that live interaction with students, just like you are having here, but, you know, a dedicated batch. Plus, you will feel like attending more and more such classes because, you know, always there is a competition going on. There are tests on every Sunday and stuff like that. And also, there are thousands of micro courses which are there. So if you have any such requirement, let's say KVPY, this, that, and you want to attend that, you can freely attend it just like Amazon subscription. Okay, I hope that is clear. Okay? Yes. Cool, cool, cool. If you already have Tattva, should you buy the course? Yes, Ranveer. I feel you should still buy the course because doubt solving, live mentoring, micro courses, test series, all this you will not get just by that material, right? That's why, Ranveer. Cool. So dispersion. What is dispersion? Spreading of light is called dispersion, isn't it? Yes, spreading of light is nothing but called as dispersion. So white light made of many colors spreads, so that is called as dispersion. So now let me give you some formulas and that's it. We are done for today's lecture. The angle by which it spreads, this angle by which it spreads, okay, this delta omega, this is called as angle of dispersion. Okay, this is called as angle of dispersion, and you can see that this angle is actually the difference of two angles. Number one, how much did the violet light deflect by? How much did the red light deflect by? The subtraction of the two. I'll repeat. Okay, this was the violet light. This was the red light. So this is the amount by which the red light deflected. This is the amount by which the violet light deflected. this angle which is there is delta omega. So it is strictly speaking delta of violet minus delta of red. That's about it. Cool. Now, what is the formula for delta? We just saw it. Delta is, come on guys, what is delta? Think about it. Delta formula, we just saw it. What was it? A was common, right? Angle of prism, this angle, that A which was there, into mu of violet minus 1, and this will be A into mu of red minus 1. I hope this is clear. Yes. And if you see, A will get cancelled and you will just have A into mu violet minus mu red. That is the formula. So you can remember this and you can derive this within few seconds if you want in the final examination. So this is the formula. Okay, so that is the angle of dispersion. Okay, so now if this is clear, the next concept is, let me put it up over here. Yes, the next concept is dispersive power. Dispersive power, and the dispersive power is how much did it spread upon the average deviation. So the spread divided by the average value, that gives you the dispersive power. Now delta omega, I just told you it is violet minus the red's deviation. The average color is always yellow. The average color is yellow. So it's basically how much did, the yellow color deviate by. So it will be delta of yellow. That's it. So delta of yellow. That's it. I hope this is clear. I hope this is clear. Is this understood? Is this understood? So Chinmay, Prabha, why don't you post a comment or leave me a message on my Instagram? Definitely I'll help you out. Okay, let's concentrate right now on the session. Okay, so this is the formula for the dispersive power. Okay, let's get going to some questions. And before that, let me also conclude with the theory. There are two kinds of arrangements. There are two kinds of arrangements. One is deviation without dispersion and dispersion without deviation. So what is the meaning of that? Dispersion without deviation means the light spread, but the deviation was not there. So average deviation, think about it. If white light is going here, yellow light will bend. So take the average deviation. Yellow light will bend because of this prism, and the second prism will make it bend again like that. So on an average, there is no deviation, but the light is still spreading. You can see that very, very clearly. So there is still some spreading over here, but average, there is no deviation. So if this was the white light, this is how it was going. This is the yellow color light, which is the average color. So the delta of yellow in the first prism should be delta of yellow in the second prism. This is the condition. That's all you need to remember. Now you substitute the values if it is given in the problem, and you can get whatever is desired as per the question. So this is what you should remember. The yellow color, how much ever it deviates in the first prism, that much only it will deviate in the second prism. Okay, Raghav, I hope this is clear. So yellow color will deviate, let's say by 3 degrees in the first prism. It will again deviate by 3 degrees. So what will happen? The average deviation will be 0. I hope now it is clear. Okay, Vijay, Raghav, everyone understood this? This is delta of yellow and delta of yellow in both the prisms. These prisms could be having different angles, different refractive indices. Okay, no problem. Very good. Next, deviation without dispersion. That means the light spreads, okay, turns, again turns, but the turn is not countering the first deviation. So the light spreads, again in the second prism it merges, but when it finally comes out, this ray is not parallel to that ray, the incident ray. You can see that there is some deviation, but the light which spread has come back. That means, recollect, what was the spread of light given by? The spread, which is nothing but dispersion. the spread or the dispersion given by? It was nothing but delta omega. I hope you remember that. Delta omega. So the spread in the first prism, okay, spread in the first prism must be the spread in the second prism. So that how much ever it diverges, that much it will converge on the second thing. I hope this is clear. So delta omega will be delta violet minus delta red in the first, and this will be delta violet in the second minus delta red in the second. That's it. That's the way to solve this. Sunil, I should not chat, yeah. Matlab, minions, what do you think? I should stop chatting? Okay, so I'll just come here. I will teach. This is spread, this is dispersion, this is delta omega, and I'll just go. Is that what you want, guys? Really? At least I wouldn't want that. And I also need some break when I'm teaching. And I love interacting with you, yeah. I'm not doing it because somebody is forcing me. Sir, you should interact with the students, huh? I love interacting. And don't worry, I'm not going to, waste so much of your time. Do you think it's a waste of time? I don't think so. And what's the use? Yes, somebody said it. Then I can do a premiere. I can just record. This is this concept. That is that concept. And that's it, done, man. So many recorded lectures are available. Why do you guys come to the live session? Because you want to see me live. There's a difference. Yes, correct. Correct. I can take a break and don't see the chats. Oh my God, that will be very, very bad. Oh my God, that will be very evil. Then what should I do? I don't know. What should I do? I should watch my room. I should watch my lights. It's very boring. This light won't talk to me. I love talking here. Hey light, please talk to me. Interact with me. Tell me how you are. Please, are you not talking? Why are you so bright, man? Okay, you're not responding. Please, light. I cannot see the chats. I'm not allowed to see the chats. Please talk to me. Why the hell are you shining on my face? It's night. Please. Oh, it's not responding. Bad. Okay, let's get back to studies. Okay, next question, 2012. A beam of light consisting of red, green and blue colors is incident on a right angled prism of face AB. The refractive indices of the material are given to be 1.39, 1.44 and 1.47. So a person looking at the surface AC will see which color? No light, green, blue, red, green, red only. Come on, think about it. Come on, think. Let's see, how do we do this? Okay, time to see how to solve this. Okay, green only, I don't know. Guys, I'll tell you what to do. When this light enters this prism, because it is entering at 90 degrees, it will also refract at 90 degrees. But when it falls over here, because this is 45, this will be also 45 degrees. Now just think about it. If it does not come on the other side, that means it should get internally reflected. So if 45 degrees is chosen as the critical angle, then what will be the critical refractive index? Let's figure that out. Remember, there is a formula for that. Sine of critical angle is 1 by mu. Therefore, if I take sine of 45 degrees is 1 by mu, therefore mu will be root 2, which is 1.414. Now, the critical angle which that critical refractive index which decides 45 degrees is the critical angle is 1.414. Now, think about it. If the refractive indices of different colors, red, green and blue are 1.39, 1.44 and 1.47, these two are having more refractive index. Correct? And 1.39 is having less refractive index. So the ones which have more refractive index, they will get reflected inside, isn't it? The only one which will come outside is the one with less refractive index, which is that 1.39, and which is that color, red color. So only red color will come outside. I hope this is clear. I hope this is clear. I hope this is clear. Okay, cool. Let's get going. Yes, red color only. Next question. I think this is the last question for today, guys. Get ready. Last question for today, I think. Or I don't know, maybe one more question. The refractive index of glass is this for red light and this much for blue light. D1 and D2 be the angles of minimum deviation for red and blue in both these prisms. Then which deviation is more? Come on, think about it. Think about it. Which deviation is more? Oh, I don't have chocolates, minions. I don't have chocolates today. And guys, these days I'm not eating chocolates. I'm not even eating too much of sugar. You know that? Even in the tea, I'm putting less sugar and eating. Yeah. Look at that. Because I had almost 50 gulab jamuns 2 weeks back. Yes, 50 gulab jamuns. Crazy it was. So I'm compensating now. Okay, let's see how to solve this. Let's see how to solve this. Okay, so let's see. Okay, what is the formula for delta? Delta is mu minus 1 into A, right? Acha, angle of prism is the same, just refractive index is different. Acha, 1.52 for red and 1.525 for blue. So mu for red is less than mu for violet. If mu is less, delta will also be less. So delta for red is less than the delta for violet, and delta for red is D1. D1 is for red, and for blue it is D2. Okay, so or violet, whatever. So this is D2 and this is D1. So hence D1 is less than D2. That should give us option A, I believe. Check this out. I hope this is clear. I hope this is clear. Okay, so that's the answer, option A. That's correct. Let's get going to the last question. Promise. Last question. Okay, let's get going to the last question. Oh my god, it's 9 o'clock already. I didn't believe it would be 9 o'clock. And guys, let me tell you, I don't even feel that it is 9 o'clock. Are you guys feeling so tired? At least I didn't feel that the time passed so quickly. Anyways, last question for today. In an experiment to determine the refractive index of a prism, you see that the incident angle is 35, deviation is 40, and emergence angle is 79. My god, crazy angle. In that case, which of the following is the closest maximum possible value of the refractive index? Well, that's not that difficult. I'll tell you what to do. Find out guys, whatever things you can find out using this. Let's see what and all we know. Angle of incidence, I1 is 35 degrees. Deviation delta is 40 degrees. Emergence, that means I2 is 79 degrees. Okay, interesting. So what can we do if we can find A? Yes, delta is I1 plus I2 minus A, right? So 40 is I1. I1 is 35 plus I2 is 79 minus A. So A will be, yeah, 40 plus 35, correct? So 75 plus 79, 35 minus 40, my bad. So minus 5 plus 79 degrees. So that A is going to be, yes, 74 degrees. So this is the value of A. Okay, I have got the value of A now. Now what do I do? Let's try to figure out if this deviation is minimum. If this is minimum, then what will be the refractive index? Let's try to do the reverse way. Mu will be sine of A is 74 plus 40 by 2, whole thing divided by sine of 74, correct? Because that is A again, divided by 2. Now what will this be? 74 plus 40, guys. Come on, 114 divided by 2, 57. So this will be sine of 57 degrees divided by 74 divided by 2, 37. So this is 37 degrees. So oops, right, go. Okay, so sine of 37 degrees. But I don't know sine of 57, but I know sine of 53, almost similar. So approximately sine 53 divided by sine 37. Now what is sine of 53? So remember that triangle I have told you, 37, 53. Yeah, this is 4, this is 3, this is 5. I have told you to remember this special triangle. So sine 37 is 3 by 5 and sine 53 is 4 by 5. Okay, so this will become 4 by 3 because 5 will go cancel out, and this will be then 1.34 approximately, because we had calculated sine 53, so sine 57 will be slightly more, so slightly more than 1.33 it will be. Now, which is the closest maximum possible value? Think about it. Here we had assumed 40 degrees is minimum deviation, but I know this is not the actual minimum deviation, so I think 1.5 is the closest value to 1.34. Yes, I hope this is clear. I hope this is clear. Yes, it's not 1.6. 1.5 is the closest value. You can see that? I hope this is clear. Okay, cool. So that's the answer. Yes, 1.5. So these are your homework problems. I have pasted the solutions in the PDF itself. You have to try these questions at home. This is your first question, 2019 question. Okay, answers are given. Don't look at the answers. Even the solutions are given. Okay, this is another 2019 question. Again, answers as well as solutions are given. So I have pasted few questions and solutions which you can solve at home, which are must for practice. And do join our Telegram group for additional updates. And I hope you will also join the crash course which has started on 28 Jan. You can check all the details. I have pasted all the timetables for the crash course whenever it is going to start. Okay, so do check them out. Oops, what just happened? Yeah, so check them out and please subscribe and like the video, guys. That's the least thing you can do, hai na? See you tomorrow at what time? What time am I going to come? 5:30 p.m. What am I going to do? Revise the entire 12th formulas. Okay, see you guys. What a lovely session. Please share it with your friends. So much of work I did. That's the least thing you can do now. If you can't join the crash course, at least share this video, yeah? Okay, chalo. Bye bye. Take care. See you tomorrow, 5:30.